Okay, example 2, solving another non-homogeneous linear ordinary differential equation. Remember that I know that it's non-homogeneous because of this 10e to the 2x here is obviously not equal to 0, so that's how I know it's non-homogeneous, and I will have to solve it by putting the two parts together, y sub h and yp. So we'll go ahead and get started, and we'll solve for y sub h using our characteristic equation. Remember, that's how we transform our lambdas, or transform the equation into lambda. So we have lambda cubed minus 2 lambda squared minus 9 lambda plus 18 equal to 0. We can go ahead and do some factoring and solving there. So we end up getting our values of lambda are -3, +3, and +2, which transforms into our first part of our solution, which is yh, which is c1 e to the -3x plus c2 e to the +3x plus c3 e to the +2x. The second part that we're going to do is to choose y sub p. We're going to use our basic rule, and so we're going to use that table and find out that since r of x is 10e to the 2x, we can choose y sub p to be similar c to the 2x. However, we do have to use the modification rule because we already noticed that we have a solution c e to the 2x in the form of c3 e to the 2x right up here as part of yh. So since this solution already exists in part of this solution, we need to use our modification rule. So we actually choose y sub p to be cx e to the 2x. Then we can go ahead and find each of the first, second, and third derivatives, and I encourage you to pause your video and try to do that part on your own. Coming back, assuming that you've had a chance to try some of that, we end up finding that yp prime is c e to the 2x times 2x plus 1. You might have it in a different form. I just factored it out so it was easier to find the second and third derivatives. As you can see the work here, and I finally did simplify that to be 4c e to the 2x times x plus 1. And then in a similar fashion, the third derivative, I ended up getting 4c e to the 2x times 2x plus 3. We can then go ahead and plug that back into the original non-homogeneous equation. So we can substitute each of these y triple, double, single primes and just y into the original equation. I'm going to go ahead and factor out this e to the 2x first because I know that we're only concerned about the coefficients here, right? So I need all of this stuff in the brackets. It's actually going to be equal to 10, which you can see as I, did that right here. And then I noticed that all of my cx terms actually are going to go away. We go plus 8 minus 8, minus 18 plus 18. So those actually all go to 0. And then we have our plus 12 minus 8 minus 9. And that comes out to be -5c is equal to 10. Let me move this up a little. And then we can go ahead and solve that, and we find that c is equal to -2, which means our particular solution, yp, is equal to -2x e to the 2x. We can go ahead and plug that back in for our general solution, adding up the y sub h and the y sub p parts. So we're going to add up this part and put it together to make our final general solution as follows. Right here we have y of x is equal to c1 e to the -3x plus c2 e to the +3x plus c3 e to the +2x minus 2x e to the 2x. We were not given any initial conditions for this, so this is as good as the solution as we're going to get. I hope that makes sense.